Alright, operations on complex numbers. We're going to roll through this pretty quickly here. We got into imaginary numbers, and we learned where imaginary numbers come from that square root of a negative. Now we're going to talk about complex numbers, which are basically, it's an imaginary number and a real number put together. It's essentially it's an imaginary number because it contains an imaginary number, but it's called complex because it has a real portion. It's like a binomial, a real plus an imaginary. And the form is right here, a plus bi, right here. A plus bi, that is the form you will write them in. Basically, when it comes to the operations of adding and subtracting, you're basically going to be combining like terms, just like you would do if you had x's. You treat the I like it's an x. So if you're doing 4 minus 2i plus negative 3 plus 2i, pretend it's 4 minus 2x, negative 3 plus 2x. What would you do? You would add like terms. So 4 and negative 3 is 1, and then negative 2i and positive 2i is 0, 0i. So that cancels out. 1 plus 0i is just 1. So you just get 1 for this one. Subtract this from this. So it's going to be negative 8 minus 4i minus 15 plus 2i. Alright, negative 8 minus 15 is negative 23. Negative 4i minus 2i is negative 6i. Okay? Alright, fractions, no big deal. 1/3 minus 1/6. We're going to put those together. 1/3 minus 1/6. Got the minus there. And let's put those together. And then we'll say plus negative I over 5, negative I over 5, minus I over 2. And now we'll need a common denominator. So times 2, times 2, times 2 here, times 2, times 5, times 5. Alright, so we have 2 minus 1. 2 minus 1 is 1. 1/6. 1/6. This is 1/6 plus this is negative 2i minus 5i. So I have negative 7i. So this is going to actually be a minus. 1/6 minus 7i over 10. Okay, so 1/6 minus 7i over 10. And that's our, so basically the same thing, just, need a common denominator there. And then here we're going to have to do some work. Radical 80 simplifies. Let's see, 40 times 2, 20 times 2, 20 times 2, 4 times 5, 2 times 2. Alright, pair of 2's, pair of 2's. So that's 4i radical 5. That's going to be minus 1 minus 4i radical 5 minus, and then 20 is 2i radical 5. 2i radical 5. Just breaking down the 20 the same way I broke down the 80. You should already know how to do that. We've done that in several lessons. I, because of the square root under the negative. Okay, so negative 1 minus 3 is negative 4. Negative 4i radical 5 minus 2i radical 5 is negative 6i radical 5. So again, just combining like terms. And we're done there. How do we multiply complex numbers? Well, multiplying complex numbers is going to be like using a distributive property, just like we would multiply binomials with x's. So one time, you could use a tabular method. It may help you use a tabular method. I'm not going to do that in the video, but set up a table if that helps you. 1 times 1 is 1. 1 times 2i, 2i, negative 6i, and then minus 12i squared. 6i times 2i, 12i squared minus, right? Now, I squared, this is going to come up a lot. I squared, we learned, is negative 1. We learned that in our last lesson. So this is a negative 1 here, times a negative 12. This is actually plus 12. So I have 12, I'm going to write this out. 1 plus 2i minus 6i plus 12. Negative 12 times negative 1 is positive 12. 1 plus 12 combines for 13. So I have 13, and then 2i minus 6i is minus 4i. Just combining like terms. 13 minus 6i. See how it's in that a plus bi form? Well, minus bi, a plus bi, a minus bi, whatever the sign is there. But the I is at the end. That's the form you want. All right, what do you do when you square something? Remember, you don't square them individually. It's 1 plus 4i times 1 plus 4i. All right, so that's 1 times 1 is 1, plus 4i, plus 4i again, and then plus 16i squared. Remember, I squared is negative 1, so this is just negative 16. 1 minus 16 is negative 15, plus 8i. Again, 1, and then this is negative 16. 1 minus 16 is negative 15. Here we have I to the third. I got to distribute here. Distribute my I, so minus 5i, and then plus I squared. Now we need to simplify our powers of I. Yesterday we learned that I to the third is negative I. So we'll substitute that in there. And we learned that I squared is negative 1, so minus 1. I can combine these I terms. So I get negative 1 minus 6i. Find the product of negative 2 plus 3i and its conjugate. All right, and it's conjugate, so we should know what that is. So we're going to do negative 2. Negative 2. Let me just rewrite that. Negative 2 plus 3i. Product of that and its conjugate. Negative 2 minus 3i. You should know what a conjugate is. All right, and we're doing conjugates. You don't have to do all 4 distributives. You only need to do the first term times the first term, and then that last term times that last term. So negative 2 times negative 2 is 4, and then 3i times negative 3i, negative 9i squared. Of course, that I squared is negative 1. It's kind of like a sign changer. So it's going to have 4 plus 9, which is 13. Here we have to both distribute this negative I through here. Negative 2i plus I squared times 5 plus 6i. And then we're going to do negative 2i times 5, which is negative 10i, minus 12i squared plus 5i squared plus 6i to the third. All right, so we have negative 10i minus 7i squared plus 6i to the third. All right, now we have I squared here, which is negative 1. We talked about that. That's just going to be plus 7 there. And then I to the third is negative I, so minus 6i. Negative 10i minus 6i, and so we have 7 minus 16i. 7 minus 16i there. All right, just division and then quick graphing, and then we're all done for today. For division, we're going to use just kind of how we did the radicals. We're going to multiply if it's a single I term, you could just multiply by I. If it's a binomial like we have here, we're going to have to multiply by that conjugate. So here we're just going to multiply by I. We'll talk about this more tomorrow as well. So we have 3i and then minus 5i squared, and then I times I, just I squared there. And then, this would be plus 5 over negative 1. That negative 1 divides in, giving us minus 5 minus 3i. And our multiply by our conjugate here, so 2 minus 3i, 2 minus 3i, 36 minus 54i plus 2i minus 3i squared. And this is just going to be 4 minus 9i squared. So Here's our there's that negative 1 there. That's going to make this positive 3 here. 3 and 36 is 39 minus 52i. And then this is going to be a plus 9 because it's I squared again. 4 plus 9, 13. Then 13 divides into both of those. So 13 goes into 39, becomes a 3. And 13 goes into 52 4 times. So 3 minus 4i would be our final answer. And then our last thing we're going to talk about here is how to graph these complex numbers. Probably one of the easiest things we do all year, because you just got to kind of think about, this is called the complex number plane. Instead of the real, we're used to graphing on a real number plane where we'd have x and y axis. This is the x axis, this is the y axis. In a complex number plane, we have the x axis and the y axis, or a bi. You can think of this as a and think of this as bi. All right, so here 5 is, this is like the x value and 2 is the y value. So we graph this as like a 5, 2. We graph this as a 3, negative 2. We graph this as a negative 2, negative 4. You just take the real component is the x-axis and the imaginary component is the y coordinate. All right, so real, imaginary, real, imaginary. This doesn't have a real, so it's 0, and then the imaginary is negative 1. This is a half, and then 1, and then this is 0, 0. All right, so we're going to graph all these points. 5, 2, you guys know how to plot points. 5, 2, we'll label that A. 3, negative 2, 1, 2, 3, negative 2, and we'll label that B. Negative 2, 4, negative 2, 4, literally just plotting points. 0, negative 1, 0, negative 1 is D, and then half 1 is right there. So that's going to be E, and then 0, 0, obviously, right there. The origin will be F. And so, very simple. We graph these complex numbers kind of just like real numbers. The real component is the X. The imaginary component is the Y. And that's it. So I'll see you in class tomorrow.